All right. So if our focus in investigation one, which was really the first part of solving systems, we solved systems of linear equations by, and let me get my pen here, by graphing. So we spent the first 3 days, all kinds of graphs, trying to find something visually. So now in this next investigation, we're going to get into solving things um, by systems using symbolic methods, okay, using our algebra skills. Okay. So it says all the unique solutions for the system of linear equations are ordered pairs. Okay, that doesn't change. We're still finding the intersection point of two lines. We're just not actually graphing the lines. We are just going to use some algebra and find the answer that way. So again, answers can be a little bit more precise because it's a little easier to do that symbolically than it is visually on a graph. Okay. It says when are solutions not unique, meaning one solution. That means when there is infinitely many solutions. So when two equations are the same, or when there's no solution. That means you have the same slope, different y-intercept, meaning parallel lines. So in terms of how we use that, well, we'll start off with a story problem. So it says write an equation relating the total number of items sold on day one, and they're talking about caps and t-shirts. Well, if you look at the items, and if you look, I hit this up here. If you look at the picture right here, there's your total number of items sold, right? So we got caps and we got t-shirts. So the total number of t-shirts plus the total number of caps is 18. That's how many items were sold. Okay. And then if we need to write an equation for the profit earned, well, now that deals with money. So the first equation is dealing with items sold. The next equation is dealing with profit, money. Well, again, putting it in standard form, if you look here, the t-shirts was $5 a shirt and the caps were $10 a cap. So it would be $5 per t-shirt plus $10 per cap, and that's $600. Okay. So what they're going to have us do is solve each equation for C, or kind of think of it as y equals mx plus b, so to speak, right? So to take t plus c equals 18, I'm going to subtract t to both sides if I want to leave t by itself. And I'm going to get c equals negative t plus 18. And then to do the other equation, I'm going to move the 5t over. And I have 10c equals negative 5t plus 600. And you know what? I made a mistake. It should not be 600. It should be 125. So you might have saw that already. So let's fix that. And it's 125 because that's the profit earned. So I'm going to divide everything by 10. And I get C equals, and it's negative a half T plus 12.5. Good. So it says since both equations are equal to C, they are equal to each other. So we're going to use both equations and solve for T. All right. And then once we do that, we'll figure out what C is once we solve T. So set them equal to each other. Negative T plus 18 equals negative 1/2 T plus 12.5. All right. Well, again, what number is further away from 0, negative 1 or a half? Well, negative 1 is. So we're going to add t to both sides. So again, solving equations, right? It's never going away, folks. I'm left with 18 on the left, and negative 1 or negative a half plus 1 is 1/2 t plus 12.5. And now I'm going to subtract 12.5 to both sides. And when I do that, I get 5.5. And since I have a fraction here, I can multiply by its reciprocal, 2 over 1, which is just 2. So the 1/2 goes away. And I'm left with t equals, well, 2 times 5.5 is 11. Okay, so down below over here, I know that t equals 11. So we found half of our solution. So if I can go back up to one of the original equations, let's use this one, and we're going to plug 11 in for t and solve for c. So when I subtract 11 to both sides, c equals 7. So I will have the coordinate 11, 7, okay? Or basically, again, the question originally asked us was, you know, how many items are we going to have to sell to make that $125 profit? You would have to sell 11 t-shirts and 7 caps. And that would be the combination that would get you a $125 profit. Okay, so what I can do here is if you go up top here, so the method for that, we're going to call this method 1. We are going to convert equations to slope intercept. Sorry guys and gals, it's hard to write. I'm on my tablet at home here, so let's try this again. Slope intercept form. And then secondly, we are going to do is we're going to set the two equations equal to each other. Okay, and then when you do that, you're going to solve, in this case for t, or it could be x. All right. Once you solve for that, you are going to replace your solution, or you're going to take your solution and replace it into one of the equations. It's really hard to write neat on this thing. And then you'll solve for your other variable. Which in this case was c, or the other case would be x. And you could take it and plug that into the other equation. So for example, when we found c equals 7, I could go in the other equation where we had c equals 1/2 t plus 12.5. And if I put the 7 in for c and go ahead and solve for t, and I would plug, well, I could plug both equations in to make sure they work, right? So this is 7. So 11 times 1/2 is 5.5. Oh, wait, I'm sorry. I think the equation was negative 1/2. Yeah, it was negative 1/2. So that would be negative 5.5 plus 12.5, and you could see that it checks because negative 5.5 plus 12.5 is 7, and 7 equals 7. So you know that's the right answer. So our sixth and final step would be you're going to check by plugging both points into the other equation, the one we didn't use to check to solve for C. Okay? So that is solving a system symbolically. You notice how we did not make a graph, right? So we're going to show some examples on another page. There is 6 of them. So we're going to, we kind of started off the story problem. We'll kind of show you how you use when you just are given 2 equations. So let's turn the page. Okay. So the first thing we need to do is put both equations into y equals mx plus b. Well, if you look here, both of these equations are in y equals mx plus b. So we can set them equal to each other. 1.5x minus 0.4 equals 0.3x plus 5. All right. So again, we want to move the smaller of the 2 over, and 0.3 is smaller than 1.5x. All right, so I'm going to move the 0.3 over by subtracting it. And we get 1.2x minus 0.4. All right. And then we're going to add 0.4 to both sides. So I'm going to get 1.2x equals 5.4. And when I divide both sides by 1.2, when I divide 5.4 by 1.2, I get 4.5. So there is our x. So we found half of our solution. The other half is the y. So we're going to take an equation that we have here. Let me use my eraser here and erase a little bit here at half so I can find. It's tough to write really small with the tablet. So I'm going to take this 4.5 and I'm going to plug it into my other, I can plug it into one of the equations. So let's plug it into this one. So I'm going to go solve for y. Y equals 1.5x times 4.5 minus 0.4. Well, when I take my calculator and take 1.5 times 4.5, I get 6.75. And when I subtract 0.4 from that, I'm going to get 6.35 for y. So I found my x and I found my y. I just need to do excuse me, I just need to do my check step now. So now I'm going to use this equation and plug both in. So 6.35 equals 0.3 times 4.5 plus 5. Okay, well, 0.3 times 4.5 is 1.35. Oops. And when you add 1.35 plus 5, you get 6.35. So you see it checks. So our answer is the coordinate 4.5, 6.35. And that is the intersection of those two lines. Now again, you can see why it's very important to do it symbolically, because that would be very tough to see on a graph. Would you agree? So much tougher, right? Much tougher. Now, in the second example, we have both equations that are not in slope-intercept form. So we got to do a little bit of maneuvering around here, and I'm going to try to write to fill this all in because, again, It's tough to write on this tablet with this pen. It's very small. So if I subtract the x to both sides, and how come we're not writing here? Here we go. I get y equals, and this is going to be negative x plus 3. So that's the first one in slope-intercept form. And the second one, if I subtract the x to both sides, I get negative y equals negative x minus 5. And I got to divide everybody by negative 1 because we have to solve for y. So y equals x plus 5. So now we took our two standard forms and put them into slope-intercept form. So now that they're both in slope-intercept form, y equals mx plus b, set them equal to each other. Negative x plus 3 equals x plus 5. Okay, so that we call this a substitution method because you're taking this and substituting it into the y. So we're substituting out the y to set both equations equal to each other. So negative 1 is less than 1, so we're going to add x to both sides over here. And I get 3 equals 2x plus 5. And then we're going to subtract 5 to both sides. I'm left with negative 2 equals 2x. Divide both sides by 2. And x is negative 1. So I found 1/2 of my intersection point. So now I'm going to take one of the equations. Let's use this first one. And I'm going to plug negative 1 in for x. And solve for y. Add 1 to both sides. Y equals 4. So now I'm going to use the second equation, plug both my answers in, and if they work, we know we got the answer. So negative 1 minus 4 equals negative 5. Well, negative 1 minus 4 happens to be negative 5, so it checks. So our answer becomes negative 1, 4 is the solution for that system. So this is the symbolic way, okay? And again, number 2, you could have done in a graph because we can see those integers on a graph easily, where number 1 would have been a little tougher, okay? So let's go to number 3. Number 3, again, we have both problems in standard form. We have to put them in a slope-intercept form. So subtract 3x to both sides. I get negative y equals negative 3x plus 30. Divide everything by negative 1. And y equals 3x minus 30. So that's that first equation converted to slope-intercept form. Okay. And the second one, if I subtract x to both sides, that's all I got to do because there's a 1 in front of the y. And I get negative x plus 14. So, set them equal to each other. 3x minus 30 equals negative x plus 14. Okay. So again, negative x is, the negative 1 is smaller than 3, so we're going to add x to both sides. We showed you that. We solved variables to both sides. 4x minus 30 equals 14. And when I add 30 to both sides, 4x equals 44. So when I divide by 4, 44 divided by 4 is 11. So there is the first half of our intersection point. So take one of the equations. I'm going to use this one because it seems to be easier. So I'm going to go up and plug it in here and say 11 for x plus y equals 14. And when I subtract 11, I get y equals 3. So now I found, hopefully, my second half of the intersection point. Now I'm going to go over to this equation here and plug both of them in, and hopefully it checks. So 3 times 11 minus y, which is 3, equals 30. Well, 3 times 11 is 33, and 33 minus 3 is 30. It checks. So our solution, our x is 11, our y is 3. There you go. So the biggest thing with this is making sure when you find your x and you find your y, you write it in the coordinate the right way. Because remember, when you write a coordinate, the x is always first. So definitely get in the habit of doing that, and don't, if you write 311, obviously you're going to be terribly wrong. Even though you showed all the work to get it right, 311 and 11.3 on a graph are in two entirely different spots. All right. Let's go to number 4. Okay, so number 4, again, we have two problems in standard form. So we're going to move them into slope-intercept form. We're going to subtract x. All right, and I get 6y equals negative x plus 15. And we're going to divide by 6. So usually we say not to use decimals, but I can tell you this: when you're using substitution, use the decimals, because it'd be a lot easier with the calculator when you are going through and plugging through. So negative 1/6 as a decimal is negative 0.16 repeating x, and 15 over 6 as a decimal is 2.5. All right, so there's the one equation converted. And now if we convert the other one, add x to both sides. All right, 4y equals x plus 5. And when you divide by 4, x is going to be 1/4 x, which is 0.25x, plus 1.25. Okay. So there's our two equations in slope-intercept form. So set them equal to each other. Negative 0.16x plus 2.5 equals 0.25x plus 1.25. So move the smaller number, which is 0.16x. And we're going to add that. So I'm left with 2.5. And 0.25 and 0.16 is 0.41x. And now I'm going to subtract 1.25 over to here. And when I subtract 1.5 from 2.5, I get 1.25 equals 0.41x. When I divide by negative 0.41, okay, that is 1.25 divided by 0.41 is going to equal I know what I did wrong. This is 0.16 repeating. So let's see if when I add 0.25 plus 0.1 and I put a bunch of 6's in, that might make a little bit of difference. Because this becomes, apologize folks, going to change our answer just a little bit. So this becomes 0.416 repeating x plus 1.25. So we're still subtracting. So I still get 1.25. But now, when I divide by 0.416 repeating, 1.25 divided by 0.41 and a bunch of 6's, you get 3. So x is going to equal 3. So there's half. Oops, lost my spot there. There's half of my intersection point. So let's go up and plug it into one of these equations. Okay. Let's plug it into the first one. So I'm going to replace this with a 3. Let's go up here. 3 plus 6y equals 15. And when I subtract 3 to both sides, I get 6y equals 12. And when I divide by 6, 12 divided by 6 is y equals 2. So I got the 0.32. So now we're going to go to this equation and put both of them in, and if they work, we got the right answer. So 3, well, this is the opposite of x. So if x is 3, the opposite of 3 is negative 3 plus 4 times 2 equals 5. Well, negative 3 plus 4 times 2 is 8, and negative 3 plus 8 is 5. So 5 equals 5. So our answer for this one is the 0.3, comma 2. Okay, so the first one had a decimal. The next three that worked out were pretty nice, right? So let's go to example 5. All right. And when we get done with 5 and 6, I'm going to show you a possible second method. So whichever method you like better is what you can use on Friday when we go over our practice. So again, I have two equations here that are in standard form that I need to put into slope-intercept form. Okay. So when I subtract, hit the button here that moved it. So we're going to subtract x to both sides. And we get negative y equals negative x minus 5. And I divide everything by negative 1. And I get y equals x plus 5. So that's the first equation when we convert it to slope-intercept form. Well, when I do the second one and add 2x to both sides, I get 2y equals 2x plus 10. And when I divide by 2, I get y equals 2 divided by 2 is 1, so this is x, and 10 divided by 2 is 5. So if you notice, my two equations are exactly the same. Well, what happens when you have two equations that are exactly the same? Same slope, same y-intercept is infinitely many solutions. Same rules as applied for graphing, we apply to the symbolic method. Up top, we came up with one answer. Okay? So you said, well, how do you know? What if we just set them equal to each other? Well, watch what happens. I guess I'll continue this just to show you why it's infinitely many solutions. If I continue this and I set both equations equal to each other, watch what happens. If I subtract an x to both sides, my x's cancel out. And I'm left with 5 equals 5. And when you're left with that, and that's a true statement, we call that an identity, which means you have infinitely many solutions. Okay? Now, in number 6, one of the last examples, before we are going to do one more, just to show you a different method, to see if you possibly like that better. And then whatever method you like the most, you can do. Okay? So we're going to show you number 6 here. Again, I got two equations. I am going to convert them, right? So they're almost similar to number 5. So we did the same equation just to the left over here. So negative y equals, that's going to be negative x minus 5. Divide by negative 1 to all through terms. Y equals x plus 5. Okay. Now when I do the other equation, if I add 2x to both sides, and I got 2y equals 2x plus 8, and I divide everything by 2, y is going to equal x plus 4. So now if I set them equal to each other, subtract the x, well, again, just like in the previous ones, the x's cancel out. However, you get 5 equals 4. Well, 5 does not equal 4, so that is not an identity. So when that happens, you have no, I don't know why this is not writing. You have no solution. And for some reason, my pen is not going to make a very good O. All right, and again, same slope, different y-intercepts are parallel lines. So again, those same rules apply to doing the symbolic method too. Now, go to a blank page here so you can flip this over the back. Let's take one of the first equations we did. We're going to show you a second method, and we're going to call this method 2. Okay, so if I give you x plus 18, or x plus y equals 18, and 5x plus 10y equals 125, these are very similar problems to the story problem we used earlier, right? We got 11.7. We just did x and y instead of t and c, okay? So in method 2, what you can do is instead of converting both to y equals mx plus b, only convert one equation to slope intercept form. So if I move this x over, I get y equals negative x plus 18, and there's my one equation in slope intercept form. And now the second part is you can substitute what y equals into the y of the other equation, the equation you didn't touch. So I'm going to take this x minus 18, negative x plus 18, and I'm going to replace it with the y there. Okay? So watch what happens when I do that. I have 5x plus, because it's 10 times y. So we're going to keep the 10 times, but we replaced y with negative x plus 18. There's the substitution for y equals 125. So that's why I took that little part and substituted them in. So now when I distribute, you can see we just substituted out the y. So our third step is we're going to solve for x. So we're going to put the 10 in there. We get negative 10x plus 180 equals 125. So when I combine like terms here, 5x minus 10x is negative 5x plus 180 equals 125. And when I subtract 180 to both sides, I'm still solving for x. Negative 5x equals negative 55. And when I divide by negative 5, negative 55 divided by negative 5 is 11. So same one we came up for in the first one, right? So now that we solved it, we're going to replace the value for x into one of the two equations. So we're going to replace x into one of the two equations. So if I look up above here, I think this equation is going to be much easier to plug it into than the other one, right? So if I plug 11, and I'll tell you what, we'll make this a different color just so you can see it better. So if I plug 11 in for x plus y equals 18 and solve for y, subtract 11, and I get y equals 7. All right, so now what we're going to do is we're going to use this equation right here, and we're going to plug both y and x into it and see if it checks. So you have 5x, which is 5 times 11, plus 10 times 7 equals 125. Well, 5 times 11 is 55. 10 times 7 is 70. And that equals 125. And 70 plus 55 is 125. So that checks. So that means our solution, just doing this a slightly different method, okay, is 11.7, which happens to be the same coordinate we got with the story problem. So that's method 2. If you like it better than the first one, again, the choice is going to be up to you. But that is the substitution method. All right. So I hope you found this video helpful.